The Chang'e-5 lander had a total of 48 hours to operate on the lunar surface. But due to constraints related to the launch window and fuel for the subsequent lunar takeoff, the actual time allocated for sampling was only 19 hours. In essence, collecting lunar soil is like digging. But the precision and complexity are comparable to performing a remote surgery. Once the Chang'e-5 probe landed, it couldn't move anymore. No one had visited the landing site before, so it was uncertain whether the area around or beneath the probe would yield enough samples. To handle these unknowns, Chang'e-5 was equipped with 2 sets of sampling tools, offering 2 methods to gather a more varied range of lunar soil.
Attention, all units. This is Beijing. Based on the flight control decision, proceed with the drilling and sampling. Apply the pre-programmed lunar soil approach.
The drill slowly advanced downward, centimeter by centimeter. The composition of lunar soil is complex, and the lunar surface experiences extreme temperature fluctuations, posing challenges to the drilling equipment. The drill bit on Chang'e-5 was made from a special material that can penetrate rocks with a hardness of up to 8 on the Mohs scale. This means that the drill of Chang'e-5 can successfully bore through sandstone, limestone, and most granites. The drill rod, composed of an aluminum-based composite material, boasted resistance and strength comparable to that of steel.
We couldn't possibly bring many types of drill bits to the lunar surface. So, we had to design a single drill bit that could adapt to all the potential drilling conditions we might face.
Impact motor activated.
Advanced by 1 millimeter. Try again.
When you hit a large rock, just rotating and cutting won't be enough to break through. The gravity on the lunar surface is only 1/6 of Earth's. So we equipped the drill with a special motor to apply the needed downward pressure in the low-gravity lunar environment. The drill must push down while drilling.
They may need to weigh and consider the biggest risk of such impact, which is that the collected samples could be disturbed by the vibrations.
This is Beijing. Core drilling proceeded normally. Over.
Proceed with extending the robotic arm to the designated sampling center.
As the drilling ended, lunar surface sampling began.
It involved a combination of rotational and lifting maneuvers, about 7 or 8 in total. Despite the complexity, these operations were carried out without any sensors. Everything was achieved through intricate mechanical design. Very ingenious.
The robotic arm moves to the lifting point after touching the lunar surface. Great Wall. Status, please. Copy that.
Through a series of precise and intricate robotic arm maneuvers, the lunar soil sample was securely scooped up.
Sample collected.
In the end, 1.731 kilograms of lunar soil was safely sealed in a container.
Attention, all units. Chang'e-5 lunar sampling operation successfully completed.
At this moment, Chang'e-5 had been on the moon for 48 hours. And the window for its lunar takeoff was approaching.
The engine ignited, and the ascender lifted off.
This mission of Chinese lunar exploration involved lunar samples collection and returning to Earth. It was the hardest lunar exploration mission ever undertaken by China. Collecting lunar soil was challenging enough, and Chang'e-5 even opted for an exceptionally complex return method.
The spacecraft underwent numerous transformations, with its mass fluctuating greatly. Throughout the mission, the probe's configuration changed 7 times. it was constantly adapting.
In the lunar orbit, between the Earth and the Moon, the small probe was tackling an almost impossible task. It was a groundbreaking technological endeavor by China in outer space. The spacecraft performed unmanned rendezvous and docking lunar orbit for the first time. The four parts of the Chang'e-5 probe would come together and separate repeatedly in the space 380,000 kilometers away.
When we launched the spacecraft, it weighed 8.2 tons, but by the time it returned, it was just over 1 ton.
The docking operation was scheduled to begin at 5:42 a.m., with the orbiter and ascender shifting into an uncontrolled mode.
Once docked successfully, the container holding the samples would be transferred into the return capsule.
Sample transfer accomplished. Great Wall reporting, return capsule hatch is closed.
Attention, all units. This is Beijing. Sample transfer completed.
It took just 30 minutes to complete the docking and transfer of lunar samples. At last, Chang'e-5 was returning to Earth. Located in central Inner Mongolia, Sudzhuang Banner spacecraft landing site spans over 2,000 square kilometers. It is China's most critical spacecraft landing site. Its vast open spaces and high visibility are perfect for locating spacecraft. The Chang'e-5 return capsule was expected to touch down here. At about 5,000 kilometers above the Earth, the orbiter separated from the return capsule. At this point, the capsule was traveling at about 11 kilometers per second, 45 times the high cruising speed of a commercial jet. If not properly slowed down, the capsule would burn up upon entry into the atmosphere.
The return capsule switches to initial re-entry mode.
With the half-ballistic re-entry technology, the capsule briefly exited the atmosphere, and then descended in a parabola to re-enter the atmosphere. This dual re-entry process reduced the capsule's speed from 11 km per second to 7 km per second through atmospheric deceleration.
Attention, all units. This is Beijing. Proceeding with the second landing site prediction for the return module. Landing longitude 111 degrees 26 minutes 24 seconds east. 111 degrees 25 minutes 52 seconds east. Landing latitude 42 degrees 20 minutes 13 seconds.
Recovery 4 has spotted the target.
Recovery 4 has spotted the target.
Attention, all units, this is Recovery 3. Requesting updates on passive location coordinates.
In the early hours of December 17th, Chang'e-5 capsule safely returned to Earth using half-ballistic re-entry technology. It landed at the Sudzhuang Banner spacecraft landing site in Inner Mongolia. China's first lunar sample return mission was accomplished.
I hereby declare the Chang'e-5 mission a complete success.
After 44 years, lunar soil came to the Earth again.
On December 17, after a 23-day journey, the Chang'e-5 lunar probe safely returned to Earth with precious lunar samples, marking China's first successful extraterrestrial sample return mission.
It was as if a sealed room had suddenly opened a window. The new lunar samples brought back by Chang'e-5 have rekindled interest in lunar research. The International Mineralogical Association confirmed that the Chang'e site, discovered by Chinese scientists in lunar soil particles, is a completely new find, previously unknown to humans. It is the sixth new mineral humans found on the Moon. On January 18, 2021, a month after Chang'e-5 returning to Earth, the China National Space Administration released the regulations on lunar sample management, encouraging international joint research in space science based on lunar samples and sharing of results. The year 2024 marks the 20th anniversary of Chinese lunar exploration program. Over the 2 decades, China has made remarkable achievements in aerospace through painstaking efforts. From manned spaceflight to lunar soil collection, from the Long March 5 to the Tiangong space station, all the technological advancements and experience gained hint at an even grander blueprint. In the 4th phase of Chinese lunar exploration program, the plan is to establish a lunar research station at the Moon's South Pole. In 2024, the first launch mission in this phase will take place.
Next, we'll launch Chang'e-6 to collect samples from the far side of the Moon, bringing them back to Earth.
Chang'e-7 is slated to land near the lunar South Pole, with its main task being a detailed survey of the environment and resources there.
The 4th phase of Chinese lunar exploration program will see the sequential launch of Chang'e-6, Chang'e-7, and Chang'e-8 probes, and the construction of an international lunar research station.
The main objective of Chang'e-7 is to find water at the lunar South Pole. Water is essential for short-term human habitation on the Moon. Chang'e-8 is also said to fly to the lunar South Pole, where it will work with Chang'e-7. These 2 spacecrafts, along with landers and rovers, will form the basic configuration of a lunar research station at the South Pole.
The research station at the lunar South Pole is a large-scale international scientific project involving multiple countries, international organizations, and scientific institutions.
Currently, about 20 countries have expressed interest in collaborating with us on Chang'e-7.
And we should unite more nations, inviting them to participate in our space activities. We'll share the fruits and venture deeper into space. This is a shared endeavor for all humanity.
Each rocket launch seems to light up the vast 380,000 kilometers between Earth and the Moon. China's lunar exploration embarks on its romantic quest, making history with ambitions. These efforts will spread such romance to the farther and broader cosmos. Humanity's exploration of space continues to drive innovation in science and technology, which in turn guides our steps further and deeper into the vast universe.